Hi, good day.
Sorry, I think you're muted. Hello, how's it going?
Good, good.
Appreciate you being here. I'm excited to talk.
Nico? How do you say Nico?
Nico, yeah. Nico,
Nico.
yeah. I've got a few more people that are hopping on in a few minutes. Looks like
Okay,
Zoom issues as usual.
okay.
But yeah, I'm excited to talk. I like what you guys are doing.
Awesome. Are you at Cornell?
Yeah, yeah.
Okay.
I'm vice president of GAIA, um, and just generally involved in the scoping and engineering side of things here.
Very cool, very cool. Do you mind if we record this so I can share this with my team?
Yeah, of course.
Okay, cool. Tell me the latest restructuring for Gaia because you guys gone through some reorganization.
Yeah, we've gone through some reorganization. As is usual at a college when people are cycling in and out.
Yeah.
Um, the founder, Becca, is doing her PhD program, and so
Mm-hmm.
she's having to take step away and take less time. So some new people are on board.
Mm-hmm.
And what we've done is before we had like multiple um, sub teams that were working on either scoping, like choosing what the project should be, and then a group that exclusively does the engineering, and then the scoping people would judge what the engineering people do.
Yeah.
And we decided that it's nicer if everybody's working on it and we're just doing the best thing that we can do to produce something that we're really proud of.
Yeah.
So the people who are working on the scoping are also involved in the engineering side of things too.
Excellent. What what branch of engineering are you in? What's your major?
I'm I'm computer science and
Computer science.
interactive technologies, but I'm like trying to be involved in everything. Like
Yeah.
uh it was hard to pick a major for me. I wanted to do everything, but
Oh, cool. Yeah. Hey, did you know that?
yeah.
So you ever hear of FreeCAD?
No, I haven't.
Okay, FreeCAD is the open source CAD software, but what we're doing right now with AI is
Oh,
generating
free CAD. Excuse
FreeCAD.
me. Yeah, yeah.
Okay, so
Yeah,
with
yeah,
FreeCAD,
yeah. I have
I don't know if you know this, but the workflows we're getting into is start with schemas so generating
Mhm.
CAD instead of just doing it by hand, just say, okay, give me this wall module that's 24-inch on center with 2x6 lumber, blah blah. I can actually say it in language, and it produces a schema that can then be used to generate different versions of that. So we're going from schema to a compiler to actual CAD. It can do the whole same process to go into assembly. So now we're basically getting the whole house through AI and schemas. Did you know that? That's possible these days.
That's exciting. No, I haven't been paying attention. I mean, I'm only familiar really with Fusion and uh like Inventor, really like the those products, but
Yeah, well, unfortunately, those
I'm wondering
well, they don't have an
they're not
easy.
open source.
Yeah, they're not open source. They don't have an easy way to script or to do schemas to easily combine. Well, you can do it in some
Hmm.
ways, but not. FreeCAD is first rate, first class at doing that kind of stuff because it's open and you can program it completely. Yeah.
Yeah, that's quite exciting.
Hmm.
What have you been like involved in making? Like, how does that improve your workflow right now?
Well, because it would take us more than 1,000 hours to generate full CAD in absolute detail, including plumbing and electrical and everything. Now
Hmm.
it's going to take about 40 hours. Major
Wow,
breakthrough. Major breakthrough. Yeah.
that's quite exciting.
Hmm.
Hey, what's up?
Hello. Sorry, I'm just getting set up really quick. I will turn my camera on Zoom and chat with you. No.
Hmm.
You're all good. Thanks for joining.
Yeah.
Yeah, I mean, got a few things. First of all, I wanted to say like what a I've been paying attention to the newsletter and the YouTube and stuff, and I'm wondering what you guys are really focused on, like
Yeah.
the future, the crash course
Yeah.
that happened like a few months ago, like October or something like that.
Yeah. Yeah. In December. So that's we're focusing on. So we're working primarily on a house and everything. So the CD Eco Home, it's a product. It's we have one for sale right
Hmm.
now. We're creating an apprenticeship program to train people to build this. But around it is a lot of different tech, including things like 3D printing for actual house parts, or even wall modules, or like plastic decking, trim, and all kinds of things. There's also development on an open source skid steer and machine infrastructure. So CNC torch
Hmm.
table, producing all these kinds of things, including RTK GPS on a skid steer. and
Mm.
a lot of different things. Like, for example, with 3D printing, there's maybe one possible thing to do would be cordless power tool construction set. I mean, that's perfect realm for 3D printing and actually some advanced design where we can.
Mm-hmm.
But the value proposition there being, if you design and build it, you can maintain it for life. That's the big deal, because it's like if your drill breaks, you throw it
Yeah.
out pretty much. This way, we
Yeah,
can
absolutely.
save a lot on tooling. So there's that part, and there's finishing all this CAD automation with AI. That's a big deal. But yeah, doing a big program in the
Mm-hmm.
summer, including spring breaks. Actually, we're doing a spring break in middle of March and end of March. So doing that to start building out the campus here. So we're getting ready for about 100 people or so, 100 to 200 people for the summer for a major program. So that's where we do a lot of the build
Really?
out. We're building infrastructure like cabins, like 10 by 12 cabins, which we can stack 4 high using a telehandler. So that's living infrastructure. Building a lot of things, including 100 kilowatts of photovoltaics on our recent structure. So a lot of construction, and then everything around the house, but also including the technology around it, including then CNC and automation, 3D printing, CNC torch tables, robotic arms
Mm-hmm.
for things like welding, or even things like robot dogs for remote robot dogs. Talking about robotics, talking about remote participation in video or in observing the actual build, like even quality control stuff. So things, all these kinds of things are relevant right now.
Mm-hmm. And you're out in Missouri right now?
Yeah, in
The
Missouri.
the main.
Yep, in Missouri, Kansas City area. So the big thing, we had a big event. 50 people showed up to build a house in December. That was freezing, but we did most of it. We're running the next courses. That's going to be we're looking at actually June 1 for the big event where we're going to do everything. Starting with a builder crash course and everything else. And that video, I don't know, have you seen the viral video on that, How I Found True Freedom, the thing about the skid steer?
Yeah, I did.
Yeah, that thing is still going. It's still getting like 200,000 hits a day. It's amazing. It came out in like October. It's insane. So
Yeah, yeah, yeah.
yeah.
I think there's a real market for like the living off grid stuff these days with people seeing how crazy housing is. Like
hmm
they're like, if I can build my own stuff, why am I doing this?
Yeah, exactly. So like with that in mind, it's like that's why we're doing the AI, because now with a CAD, because now you can take a regular person, they can take all the part libraries and say, okay, CAD, AI, chat, just give me a new version of this house with these walls arranged like this, and it'll do that all for you. So that's the next major milestone, so that anybody can design their own engineered house, because the engineering is already in the modules. So that's how it works.
Yeah, that's quite interesting. Have you like done any research into like the quality control of like the AI? Like, is it 100% like
Well, you can
structurally stable at every time?
Well, the question is, do we feed it with the right content? If we engineer the things that we put
Yeah.
in there, you have it. And then we're actually talking about quality control. The thing we want to set up here is we have our building, you have a camera overhead, and then you take a picture, and using OpenCV, Open Computer Vision and
Hmm.
AI, you can simply
Of course,
say,
yeah.
okay, compare that against the actual CAD file, give me the quality control. How far off is this? So automating processes like that is game right now. So that's exciting, like information work aspect of this stuff.
Yeah, that's interesting. Yeah, I'm just curious about like I don't know. I can't imagine what the liability is like if you're like building production houses with AI. Like
Okay, well let me
I'm wondering what the
tell me what's the question.
I'm just interested. Like not questioning you. I'm just 100% interested. Like if AI is building these houses out of the modules that you build, of course, that are up to code, everything like that. Do you have to have like a structural engineer like
Okay.
check off on that?
Yeah, so this gets very interesting, and this is exactly kind of the things we're solving to get this quality control and code. There's plan check. You got to go take this stuff to your building department. They approve it. Sometimes they'll ask you for engineering. Like we have the photovoltaic system and some innovative truss designs. Okay, yes, we're going to need a structural engineer and electrical engineer to do that. Now, what do we do? Well, first of all, with an automated CAD, we generate that whole compliance package to submit to the building department. Okay, great. Now we will need those engineers up front, but if we do it once and we have a stable version model, then if we can use that engineering as a reference design so that the next one you build, hopefully the building department accepts it, saying, oh, well, that's already been built, you already did that last time, say it's in the same city, then you can say, oh, okay, now you don't need it anymore. And once enough of these things get built, people start getting used to it, that's going to be a non-issue, saying, oh, well, this was built 100 times over, yeah, this is legit.
Yeah,
But
that makes sense. I mean, I think we've seen. Go ahead. Sorry.
well, I was going to say, like, we have to, that's not free lunch, you got to do that. But if it's open source and you can provide reference designs, then other people can use them. It's not like somebody does a build and that's completely in-house. None of this is open and replicable because it's engineers just going in a back corner. But here we provide them open formats. We can even say, hey, here's the whole engineering package that we already provided. Just sign off. They don't even have to do any work. So it's actually going to be easier for the engineers. Easy money for the engineers.
Yeah, it's interesting. I mean, I think, yeah, it's certainly on the table. Like we've seen with self-driving cars, I really thought that was going to be impossible to convince people to get on board with, but we're seeing it now.
Yeah.
Sorry, I should introduce my people.
Yeah.
Hi, Iris. Hi, Alyssa.
Hi, it's so nice to meet you.
Good to meet you. Yeah. Excellent.
Yeah.
Iris? Iris seems to be muted.
Yeah, I think I did hear that. Thank you. Oh, sorry.
Well, I was okay. Microphone not working.
Yeah.
Yeah.
No, please go ahead.
So how do we get the most out of this meeting? What do we like to accomplish today?
Yeah. Well, first, I appreciate you talking about what you guys got going on, because I think our main goal is just to find a spot that we can really help you guys improve your life, not just do something that isn't making a difference. I think I appreciate we've had partnerships that I appreciate, but like seems like they've got something going on, and we would love to be able to like really slot in a place that could really help. And I'm wondering if there's like something that you've got going on that you feel you really need support on.
Well, it'll be if there are people into the CAD AI assisted CAD workflows, that would be something, because we're developing this whole process where anybody can do this. So we should be able to teach anybody to do this pretty rapidly. In fact, we're trying to do basically a short course, a crash course on this. Like in 5 days, we can teach you everything about this, so you can really be useful in terms of doing design, putting part libraries into play, say on a house, to generate new models. And there's everything in the house. I mean, you got everything from actual design, then you can think about digital fabrication. There's a 3D printing aspect. That's a little large scale, but the things that are small scale, say that a college group could do, there's definitely the design, the CAD automation part, but also things like on a small scale. What about things like, do you have any interest in doing things like the cordless power tool construction set? Because we go through a lot of power tools, and those are easy things to 3D print, including battery packs and all that. I don't know if that's any interesting to you guys, but that's something I would suggest immediately.
That's super interesting to me. How are you feeling, Alyssa?
Yeah, for sure. It's actually funny because I'm going to be working for a power tool company this summer, so I think it would be a good, actually, just connection to that.
Perfect.
Yeah.
Oh, wow. What power tool company is that?
Milwaukee Tool.
Milwaukee, no kidding. Yeah, so that's exactly it. So Milwaukee, DeWalt, Bauer, like all these, those are the kind of things we use. And the thing is, the issue to address is when they break, you pretty much have to throw them out because you can't fix them. They're not designed to be fixed. And if we do it ourselves, even think about this, even if it's it works and it's good enough, well, it may not be as polished or refined as your Milwaukee, but if now say the Milwaukee breaks and it dies in 6 months, well, the open source is a clear winner, because you can keep using it. You can fix it if it breaks or whatever. So it's just the value. You just get so much more value out of the open source route.
I see. So if I'm understanding correctly, you're saying that like the open source, I guess, templates and way of just printing is just a lot more, I guess, economically kind of sustainable in the end because you can easily just reproduce it.
Yeah.
Um, I
Yeah.
see.
Okay. So say, okay,
Yeah.
somebody has the drill, they drop the battery, the
Hmm.
connector chips. You
Hmm.
pretty much have to throw out that battery because
Mm.
you can't
That's
plug it
true.
in without holding it, and it's useless, right?
Hmm.
So if it was open source, all you do is open it up, take out the
Hmm.
batteries, maybe do some spot welding,
Hmm.
then 3D print your new case, and you've got a 100% battery again, as opposed
I
to
see.
zero. I mean,
Oh, yeah.
throw it out
Infinitely
versus,
repairable.
yeah,
Yeah.
that's a big deal. To like 10x
Yeah.
value increase right there.
Yeah, I definitely see your point because you also have to go through the hurdle of like trying to contact like Milwaukee Tool, for example, and go through like customer support, seeing, having to see if they will
Yeah.
do any fixing on the end, and you'll probably
Oh
have to
yeah.
pay for it anyways. Yeah.
Yeah, yeah. I
Mhm.
mean,
Yeah.
shipping and all that. I mean, if you have a simple
Hmm.
3D printer, you
Hmm.
can fix it right there. And it's a 3D printer. You can
Hmm.
get it for a few $100. And if we're running a real operation like we are, then that's an easy investment to make. So we can control that. Because I mean, we have a whole
Hmm.
stack of in the workshop. I mean, we got this whole pile of broken tools, and it's just ridiculous. And it's just like one
Hmm.
little thing that's
Hmm.
wrong in each one. You know?
Yeah.
Yeah. I'm interested on what sort of filament we're using. Like, is this done with like traditional like
Yeah. I mean, there's
PLA or?
Yeah, yeah. I mean, ABS, like for example, if you're doing, for example, cordless power tools, I mean, typically a lot of those casings are ABS plastic. hmm And then, so
Hmm.
ABS, and there's some rubber parts, but the rubber is printable. There's thermoplastic urethane, TPU. That's basically
Hmm.
printed rubber, so you can do that. And you can do that. So we build our own 3D printers, and we haven't touched that for like 5 years or so now because we've been working on a house. But we're planning on getting all that infrastructure back out, including sourcing a filament maker that we can actually make plastic filament from trash. Okay, so even better, you take that broken power tool, shred it up, and make it into filament again. That's the kind of systems we're trying to
Hmm.
get into.
That's really exciting stuff. I
hmm
think so. I saw a lot of research recently into um, reusable or just filament made from old parts, and it seems like a really promising
Yeah,
way to reuse like this old plastic that can't be recycled and stuff.
absolutely, and that's known technology. It's kind of low-hanging fruit, and you have to have your shredder. You have to have an operation that actually does that efficiently. Right now, we're actually
Hmm.
looking at sourcing a big filament maker from China, since we're not, we can't build it ourselves right now. We're not set up for that right now to do all of that. But then open source it. Like once we get it, study it, open reverse engineering, open source it, and make a good one because um, they can be pretty expensive for the production ones. Like yeah, I mean, once again, it's if you build it, open source it, it's going to be much lower cost.
Hmm. What about like the non-plastic parts of the
Yeah.
tools? Like,
So
I assume you can't print the bits or anything like
yeah, I
that,
mean,
but
if you have CNC machines, you could do that, but right now we don't have to because those parts are widely accessible in the supply
hmm.
chain. Like you can get a chuck very easily. You can get the motors. You can get the switches. So it's a matter of here's the whole drill. Here's the 3D printed structure. Here's all the vitamins or all the special parts that you simply buy, just like anything else. But then, um, first of all, it's readily accessible off the shelf. So that's great. A chuck is a complicated thing. The gearbox there, yeah, the clutch. Well, you can get that right off the shelf, and that same could apply to, okay, so you got a cordless saw. Well, you can get those motors, you can get the blades, you can get the spindles, you can get all those parts. So now, if
Hmm.
you understand that build process and the supply chain, I mean, that's a perfect, simple engineering question that you can be producing these things. If the open designs exist, anybody can do this anywhere. Now the problem is, like
Hmm.
you look at whatever Instructables or like all over the internet, there's a little bit, but there's not a really good one out there that you can replicate that's really good. You know, it's like all these
Hmm.
tinkerers out there, but they never really coordinate to high quality of product development. And that's the gap we're trying to address with open source ecology. You have to have a dedicated, focused effort to make it happen, because the designs are not appearing out there. And if somebody does have a good design, I mean, a lot of times it just disappears, it becomes proprietary. So there is a lot of prior art of the components, and there's even like 3D printed motors and things like that. But the idea is to refine it, to productize it, not just a one-off hobbyist thing. Take the effort to document it, put it in CAD, make it widely accessible.
How about the batteries? Are the batteries available off shelf?
Yeah, so off the shelf you have the 18650, those cylindrical, very, very common batteries. Yes, they're widely available off the shelf.
So you just build like the casing that slots into like the bottom of the drill and with 3D printing and good to go.
You got to do the casing, you got to put some metal in there as the electrical contacts. You might either do like some kind of a spring-loaded mechanism or just spot weld, using a spot welder for the contacts. It's really a geometry design question. So how do you make it ergonomic? How do you fit it all into that 3D printed casing? And also then you have the idea, okay, well, let's make these universal tools that say you have a handle and a drill, like a handle and a motor. Well, put all kinds of different tools on top of it. So it could become a jigsaw or whatever, anything you want it to be. So literally, like in a sense of, we talk a lot about construction sets as opposed to just one tool. It's you can design it as a construction set with interchangeable parts.
Yeah, that's awesome. Go ahead.
Oh, thank you. I just have one question. I know you mentioned that, designs are like kind of I guess, standardized or cohesive design is hard to find online. So I guess I was wondering like how you go about finding the designs to kind of study and document and put into CAD. Like, where are you trying to collect?
First thing I would do is open source cordless drill, put it into your search, and then you might have some, and then some of them might already have the files, and maybe you use those, or you just go to a product catalog for, say, a cordless drill, and it has all the dimensions in there, so you can just draw it up from scratch. The other way to go about it is you say, okay, I know I've got these known components, such as, okay, here's a motor, here's the chuck, here's the battery, here's the switch, here's all these components. Well, their geometry is predefined. So if you start with that, you have to say, well, there's only one way they can be put together, or like you have to figure out a way that they go together in a compact form factor. So you just start logicking that out. You can put all the parts into CAD and just start drawing the shape around it.
Interesting. So it's like a combination of looking at the stuff that's already out there and also kind of reverse engineering things.
Yeah.
Okay. Yeah.
So what's your major?
I'm doing electrical and computer engineering.
Okay.
I'm currently a junior.
Okay.
And also, I think I remember you mentioned you're currently located in Missouri. I actually did a co-op there last fall.
Oh.
I worked at electric utilities. So.
Oh, yeah? Like where?
Ameren.
Oh, Ameren, yeah, that's the power company.
Yeah.
So what, like Kansas City or?
I was in St. Louis.
Okay. Yeah.
Yeah, in their
yeah,
HQ.
Cool. Okay.
Yep.
All right.
Yeah.
I just pulled up the open source wiki on the 3D printed drill. I'm curious, what like step of the way are you guys right now? Like, are you? Go ahead.
Yeah, it's all what you see there are just concepts. So we're at the conceptual design phase. It's basically break down the product into different parts, and then start designing. We just basically put down the specification, like, oh, well, it has to have a universal battery pack. It's all the different properties of it. But one of the things you'll see in there is probably I'm talking about, well, make it an interchangeable tool set so that you can put different implements, so-called, or different tool heads on it. So say it could be a drill, it could be a saw, jigsaw, whatever, cutting tool, fan, blower, like just put all the different heads on a handle. So there's like hundreds of different useful tools that you can have, Yeah, like a reciprocating saw or a multi-tool kind of a cutter thing. Small blades, larger blades, jigsaws. I mean,
Yeah,
lights, vacuums, um, routers, anything. Yeah, but I
yeah.
mean, you
It
got to
also,
start. You got to
I
pick
mean,
one. Start with one and do that.
of course, yeah, yeah. It also seems interesting. I don't know. This maybe is more in the hobbies realm over production, but making the parts interchangeable with an already commercially available
Oh yeah,
drill, right?
oh yeah. So for example, like if you want to talk about a battery, yeah, just put in a DeWalt battery format, or
Yeah.
make and also make adapters. So say you do it for DeWalt, which we primarily use DeWalt here, so that's why I say that. But make an adapter, so now you can put Milwaukee batteries on it, or use this adapter with Milwaukee tools, so you can use DeWalt batteries. So adapters both ways. hmm Absolutely, and we're going to be for that. I mean, yes, select the trick would be to select parts that work. Like for example, if it's a simple motor, well, you might want to say, okay, well, what motor does the Milwaukee use? Let's find it out. Can we simply get that off the shelf, or are they using their own version, proprietary thing that you can't get anywhere? Ideally, we would do something like, oh, okay, well, this brand of tools uses this motor and it's actually available. We might want to go with that because then you have a larger supply chain for that because it's in a very well-known tool or whatever. So things like that.
Hmm. Yeah, totally.
hmm
Yeah, I mean, this is something that I think definitely we'd be super interested in tackling, and something that
hmm
is definitely within our wheelhouse, I would say. Um, yeah, fortunately, Cornell gives us some pretty good access to 3D printers and such, so
Yeah, yeah, absolutely.
seems cool.
And as far as the team, like, how do you? So you would recruit? Is this still that you're trying to get different branches across different universities? You're trying to get collaborations with other schools, or is this
Right
more
now,
just Cornell?
right now, I think it became a little bit too much of a hassle to communicate with
hmm
the groups outside of Cornell.
Yeah.
And we had like specifically we had some people that were handling that who like are like stepping back a little bit. So right now we're just trying to like go hard and get as many like really excited people in like as many different fields as possible at Cornell
hmm
that can dedicate some time to making something really awesome.
Okay, so the way to entice people. So I mentioned in the summer, June 1, we're gonna have 3 months of the Summer of Extreme Design build. We're going to build these things.
Hmm.
So we're going to have a session where we actually do like whatever prototyping and rapid design, wherever we are at that time. If we have a finished design, then maybe we just work on optimizing it for production, or we might design like, okay, here's now a new different tool head or maybe a larger battery or whatever. So we'll have a dedicated session around that. hmm If any leadership would arise in this project, somebody who's really on top of it and can actually teach others, we'd want them to teach during our session if that's possible. During if they can come out,
I
either
mean,
or even remote. I mean, just remote too. So okay, here's how we designed it. Here's the part libraries in CAD, in FreeCAD, and teach everyone else. Because I mean, okay, so cordless power tools. They're like I think in the billions of dollars of market size. So imagine if people could actually
yeah, I
start
saw that.
making this. I mean, it's huge. It's a huge opportunity. It's not like a trivial thing. It's a major thing for the global economy.
Yeah, that seems awesome. We're already like sort of recruiting people with the idea that we've been planning trips over the summer.
hmm
So that'd be great. Yeah.
Oh yeah, that would be awesome. So you already there's various kinds of events that like for the particular for your group, or you're talking about for in Cornell in general.
Yeah. Yeah. So well, Cornell has a travel grant that allows engineers to go work on important projects, but then our club in particular has been uh, working on planning trips. Alyssa can talk about it. She went to Peru with Wind Aid to work on
Nice.
a controller for a wind turbine. Yeah.
Yeah. Yeah. It's exciting.
Yeah, for sure. So yeah, we'll hopefully be able to keep it up because I think it was really nice getting to like see your prototype actually and actually make it in person. And actually see that there's potential for it to, actually make an impact.
Yeah.
So
Yeah.
I do think, continuing the summer programs or trips is definitely something I want to
Yeah.
do. Yeah. I think also I have another question. I know you said there's a lot of things you can make,
Hmm.
even just within cordless power tools. Is there anything you're, focused on or any kind of
Hmm.
areas of focus that, you think that we might be able to fit in with, or is it just kind of open-ended?
I mean,
You'd
there's,
like us to just, our
I mean,
interests.
the top. I mean, the cordless power tools I think are a good fit. There's also things like with open source robotics, like say between 3D printers and robotic arms, or even like robo dog kind of concepts. I know there's a lot of like open source. That kind of technology is becoming highly open source. So for the robo dog, actually, so the quadruped, that's actually very useful. Imagine that we have a workshop running here, and you have remote participants who can either do, things like video production, quality control, or just communicate, just observing the actual workflow. That could be a great educational tool. Now I think that's a little more complex. I don't know if, but that is exciting because RoboDog, it's like that can actually be controlled over the internet by remote participants. That's exciting. There's robotic arms, like for welding, because we're going to be doing structural welding, like of just working with rebar, actually rebar-based trusses and structures. So even either for buildings or even things like tractor frames, there's robotic arms for welding. And then there's other tools. I mean, there's all the tools. So 3D printers. We have built our own 3D printers. We're upgrading them now to larger size and more production grade, including high temperature build chambers, which those kinds of printers are pretty expensive. So there's definitely that kind of stuff. But I mean, that requires some, I think, probably more developed know-how in terms
Mhm.
of, I think the skill set there might be a little higher to actually
Mhm.
do meaningful design and prototype and iterate that. I mean, if
Mhm.
somebody's super
Yeah.
interested in if
Right.
someone there was a good stakeholder locally, that would be awesome. But I don't know. It depends. So there's these things. What else? There's also, I mean, a big thing for the house itself is inverters, just open source inverters uh, for the photovoltaic part.
Sweet.
Those are things, once again, in terms of the lifetime design aspect.
Mhm.
Those things break like every 10 or 15 years. You have to
Right.
replace it. And it's probably like some little thing that burned out and you got to throw it out. So it's like, once again, if we can lifetime design that, that would be a big contribution. Now, besides that,
Yeah.
we're doing much bigger things. So things like here's open source skid steers, tractors, and heavy machines. That kind of stuff we'll be building this summer as well. That
Mhm.
probably might be I don't know if that's probably a little too large for what you can do, unless somebody really wants it and organizes around that. But I mean,
Yeah.
we are certainly interested in that, but that's kind of larger scale stuff.
Yeah. It
Hmm.
does sound
Yeah,
like.
that definitely
Yeah. Wait.
seems
Sorry. No. Feel free to finish, Nico.
not no, that just,
Yeah.
definitely seems a little big, especially just the manufacturing side of like a tractor. Like we don't have the space at all
Yeah.
for that.
Yeah.
But it's funny the in another project that I'm working on with some other people, we're building a robot arm for a considerably yet less useful purpose, which is a rock paper scissors machine
Hmm. Yeah.
with like
Yeah.
computer vision. That's funny. Certainly
Yeah.
not available for
Yeah.
living.
We're interested in more like
Yeah.
something that, like, for example, for a welding robot, that would be like you'd have to have like 10 kilogram or 20 kilogram
Yeah,
Mhm.
ability. So yeah, it's
yeah,
probably
clearly
larger.
not.
Yeah. I think
Yeah,
it'd be good
the
if. Oh, sorry. I
I was gonna say
interrupted you again. Yeah.
the power drill seems like a perfect project for us, especially because
Mhm.
with the new people bringing them on, like teaching them about CAD is just such a useful tool,
Mhm.
and I think that would be like a perfect way to introduce them to engineering.
I would also say for any people who are entrepreneurial minded, I mean, pitch it as, hey, start your own business, making this power tool construction set that's
Hmm.
unlike anything in the world because it's lifetime design. I mean, there's a huge
Yeah.
enterprise
Yeah,
opportunity there.
Yeah.
100%.
That's a very
Yeah,
good point.
yeah, and we have the startup incubator
Hmm.
nearby.
Right.
Someone wanted to get involved in that. Yeah.
Yeah, and the only
Yeah.
thing it would be like if we're working on it, that would be open source, but then that means anybody can do
Mhm.
that, and many different operations like that can start up all over the world.
Yeah.
Hmm.
100%.
Yeah.
Yeah.
Yeah,
I
I
think that
definitely think it's good.
I think
There.
that's certainly something we can handle, and quite interesting and important, I think.
Yeah. I think it's great also that I feel like since like students will get to be involved like directly in the design process, it'll also, introduce us to the other concepts you need to know. Like I think
Hmm.
since I'm like electrical and computer engineer, I still have to, understand how like charging works, on the power drill, any kind of like thermal, like electrical limits or,
Hmm.
boundaries to navigate. So I think it's a good way to expose, students to different parts. And I think also students are generally more excited about like design. I think when a lot of people I've talked to think about engineering, they think about like the actual designing part. So I think it's a good
Hmm.
good appeal to them in
Yeah,
a sense. So very
yeah,
exciting. Mhm.
awesome. Oh, the
Yeah.
other thing is, so we're
Mhm.
gonna have spring breaks middle of March. Now that's gonna be a little different. So this is more about the house builds, but we're gonna be building cabins, like 12 by 20-foot cabins that then we're gonna stack vertically for housing, and it's gonna be like that's gonna be pretty much like student housing, with also different modules for like kitchens, bathrooms, thermal
Mhm.
batteries, utility modules, and things like that. So
Mhm.
we're gonna be doing that actually. Middle of March. So actually, I don't know if maybe you guys can promulgate that there as well. Because you guys, when is your spring break?
I believe
Uh,
it's kind of weird. I think it's in February, right? I
so
don't
yeah,
know.
we have two breaks.
Hmm.
It's kind of so we have a February break on Valentine's Day, and then we have spring break starting end of March. I think it's like
Mm-hmm.
March
End of March.
28th, and
Yeah.
then we have like a week for that.
Mm-hmm.
Yeah.
Yeah.
So
Yeah. Yeah. Yeah.
What
Yeah.
time did you guys say you were going to start that?
So I mean,
Earlier March
we
or?
didn't put the announcement yet, but we're gonna do one March 14, and we're gonna and probably like
Hmm. Okay.
21st. But I mean, we can also consider like the end. We haven't put those dates down, but definitely something like mid March, and then towards the end of the month or even April. So we'll take a look at the different schedules, see who's expressing interest to see when we
Yeah.
put the date on. Hmm.
Yeah. We can keep in touch about that. If we were to like uh take on this project, which I'm certainly interested in with the power drill, um, I guess do you have any advice to, I don't know, like is it should we should we just like go for it, I guess, or is there something that we should keep in mind
I
regarding
think,
it? Like,
I mean,
should we?
here's the thing: like we
I
have
don't
to
know.
do it. We need to do it for various reasons. Like one is we go through a lot of power tools, and we want to have control over them and not produce all this waste. So I mean, we're absolutely going to do it. So I mean, I would say just jump in it. I mean, because there's all kinds of projects, but I think this one is really tractable and tangible, and I think it
Hmm.
could allow for quick iterations. I think just go for it.
Hmm.
Um,
Yeah,
and we,
I
we
guess I
definitely
guess
need
my
it.
yeah, totally. I guess my question, which I
Mm,
couldn't come up with the words with
no.
before, is in terms of documentation and stuff,
Mm.
what's the best way for allowing others to be able to replicate the work? And especially what about the documentation early stages where you don't have like something that
Oh
you
yeah.
think people will actually be able to use?
So let me share my screen with you real quick. So on the
Yep.
where's that share screen? No, I don't have an ability. But if I'll show you
Oh,
a
I
link.
can I can allow
Okay.
you to
Yeah, go
share
ahead.
screen. Let me see. Oh yeah, allow participants to share screen. There we go.
Um, yeah. So if you take a look at entire screen, share. Um, Well, if you go to any, like, okay, so here's the CD Go Home 4, right? So what we do is we embed, can you see that?
Yeah, yeah.
So this is a standard template, and it's basically like 20 steps of development. So you start with requirements, industry standards, conceptual design. Conceptual design, all the stuff that you start thinking about it, design and everything, when you don't have any real design yet, throw it all in there. And then you go to more like technical design, CAD, like bills of materials, build instructions, life cycle design. But okay, how do you do this? Well, we have a little template. So for example, if we want to do the say the Cornell cordless drill right here. Okay, so this is the wiki. Anybody can log in there and edit it. So you can actually seed that entire template. It's a template that we use, and all you got to do is do. So it's actually there's a way that you can put in templates, and it's in double brackets. So that template is, I mean, to substitute that thing. It's a development template, dev plus, we call it, and then we pipe in the Cornell cordless drill. Okay, and what that does, it seeds that. See what it did already? You got it all in there. So you got all the steps. Cornell cordless drill. Start with conceptual design. So what is our conceptual design? I mean, requirements. So here, I mean, you want to, so you see I got some stuff in there. You'd go with requirements. So when you start, like, what is it? Like, now you can say, we are going to do the world's first fully open source productizable drill. So it has to be aiming towards a product. It's got a standard battery. It's got battery interface connectors, like for different batteries, whatever we decide. I mean, you guys can get creative on it, but yes, I'm gonna stop sharing. But that's basically it. So a template like that, just any place where you're documenting publicly, so that anybody else on the team can look what's going on. A lot of times, what we do is inside those in the documentation on the wiki, where it's just text edit, you can embed. We use Google Slides a lot. So, for example, if you're, let me share again, in the CD Go Home 4, for example, where we were working on it. For example, in build instructions, well, you got plenty of docs here, but we would embed, like here's an embedded Google presentation, which has got now like a ton of pages in there, right? So, and you can edit that in there. But typically we work between Wiki and things like Google Slides, where the cool thing about Google Slides is a lot of different people can be collaborating on it at the same time. So say you're doing a design, you get a design session with all your people, you can be start breaking it down into modules, whatever, you could do diagrams and all kinds of things. So just use the online tools that allow you to do it. If you have CAD, you know, that's the biggest resource. Start uploading it to the CAD. You know, like CAD is the big one. That's the one here, 3D CAD item 6. So you just click on this, and here, for example, if you got a file, like you just did a file to share with others, all you need to do is file first, what a iteration dot. So if it's in FreeCAD, FCSTD, so you can upload it readily. It will ask you for the file and stuff like that, so you can upload it. So between Wiki and things like Google Slides, it's pretty simple to get people on board to do the collaborative documentation. But that's the big deal. Like, you got to have people, like, as soon as they start, have them start jotting down, get used to the idea that you're working openly. It's in process documentation. That's the big deal, because otherwise you're going to lose all that stuff. And that's one of the challenges. Like, people don't like to document.
Yeah, I'll definitely make sure to figure out how to do everything, and then have a workshop like first thing showing everything like that. And then FreeCAD, I assume, is preferable over any other.
Absolutely, because it allows you to do the workflow that we do, which is the scripting or schemas, basically the AI automated workflows. FreeCAD is first class in that. All the other packages, they're not as good.
And FreeCAD does it run? I'll just look into
Yeah, all
everything.
the platforms. Yeah, you got it
Uh,
for all the
runs on
platforms.
everything.
Hmm.
Sweet. Yeah, that's great. That's perfect for me. Unless, do you have any other questions?
Um, I don't know if this was addressed before, but I was just curious. Yeah, if we were to, move forward with the project, are there, is it up to us to kind of create our timeline and deliverables besides, like document everything on open source, making it accessible, or do you have
S-
like some things planned
Well,
in mind?
so the only plan
Mhm,
is we want to be
mhm,
able to build this in a Summer of
mhm,
Extreme Design build. So
mhm,
before that, we can go through a lot of different iterations and prototypes. Like,
mhm,
okay, maybe we prototype the battery pack, the whatever, the everything else,
mhm,
so that in the Summer of Extreme Design
mhm,
build, we've got a pretty tight workshop that people can participate in
mhm.
to make multiple copies of that.
Okay,
So we'd
got it.
have the,
Mhm,
the print cluster running, we'd be making all the parts,
mhm,
doing some of the design processes. So think about an educational event. So the Summer of
mhm,
Extreme Design Build is a residency where we invite different people, and then the public signs up to do this if they're interested in learning how to design and build just about anything, right? So we do the
mhm,
housing part,
Hmm.
we're going to do the skid steer, we're going to do the cordless power tools,
mhm,
we're going to get into other areas, including compressed earth block press
mhm.
and sawmill and stuff like that,
Okay.
like a lot of
Mhm.
crazy stuff.
Wow.
But the idea is to make it a very interesting experience for people to participate and learn a ton and get real product out of it. So, say
Okay.
we want to be at a place where when you build it, it's not going to fall apart, right? So, the
Right.
schedule is okay,
Mhm.
let's do some serious
Yeah.
prototyping, let's test
Mhm.
everything works, do the sourcing,
Mhm.
but we can coordinate that. But the idea is that for the summer, we actually have a decent version to work with, and if
Mhm.
possible, involve as many other people as possible. Like First Robotics,
Right.
I have a friend who runs that in Canada, for example. We're going to try to get
Mhm.
them on board, see what they can do.
Mhm.
So as we go along, try to publicize it that we can get people on it. Like now with the
Mhm.
Instagram audience, we've got 1 million followers. We can call it out. Hey, we're doing a design sprint to do this. Now,
Right.
it does require some onboarding. So what I'd like to do, like pretty quickly, like within the next month or so, provide this immersion training, like a 5-day immersion training where people can learn all those skills. Here's how you use the CAD. Here's how you design things. Here's the part libraries, say for the cordless drill, or the more like the development process, so that if we call out for a design sprint collaborative, or you guys work on your
Mhm.
sessions back at Cornell, you guys have a good footing on the collaborative development method, and then we can do call outs like maybe a design sprint, like, okay, so we got so far on it, how about
Mhm.
if there's a lot of interest in that because we've got enough work done on it, then we can say, oh, okay, well, in this design sprint we're going to develop the
Mhm.
circular saw version of this or whatever, things
Mhm.
like that. So we can play with it, but it all depends on how people get involved and how much they put into this.
Okay.
Now we can
Wait.
coordinate
Yeah.
on a schedule, and if you guys, I mean, I
Mhm.
have to know like, well, what, how many people you got that would be interested in this,
Mhm.
and we can
Hmm.
coordinate
Yeah,
the effort. Hmm.
we'll definitely have to um, talk to some other people on our team to see if we're ready for it and like that we're excited. I'm definitely am, but I think we'll talk to the rest of our team, see if we can get a solid group that's really interested, and then we'll reach back out
Hmm.
in the next 2 days. We have sort of an onboarding session on Tuesday where hopefully we'll get some more people that are excited, and then
Yeah.
Mhm.
So
I'll
that's what I would propose right now, the cordless power tool
Mhm.
construction set. But if somebody, like, you don't want to throw somebody out
Mhm.
because they're really super excited about something and they have
100%.
good expertise.
Right.
Like if they can propose something that they can knock out of the ballpark, we might want to consider that. So keep that
Yeah.
in mind
Yeah,
as well.
that I love that. Like in my
Mhm.
recruiting form, I make sure to like have a section that says, "Are you super passionate about something? Please tell me. I want to make it happen for you. I want to make sure you can do what you're
Exactly.
interested in." Yeah.
Hmm. Hmm.
Well, that's
Yeah.
awesome.
Yeah, it's
Yeah.
awesome.
Appreciate
Yeah.
you for your time for sure, and
Yeah.
I'll sure be sure to be in touch.
All right, Nico, Alyssa, thanks so much. Yeah, let's see if we can make this happen. and
Yeah.
Awesome.
build it
Thank you.
Sounds
sometime.
so excited. Yeah, it was
Okay.
great meeting you. Thanks.
Yeah, great
Thanks
meeting
so
you.
much for meeting with us.
Yep. Thank you.
Yeah. Bye, guys.
Appreciate it.
Take care.
Bye.